Hello, welcome back to the stream, and tonight we're just going to be carrying on with that same exam paper that we had before, and it is let's just remind ourselves what the paper is. We're just going to be carrying on with that same. Okay, just checking this down there. Yeah, so the paper is May-June 2023. So summer 2023, and it's paper 2 and it's paper 2-1, which I believe was the UK paper. So we're going to carry on where we left off. We got up to question 5, and for question 5 it is a errors in code question. An algorithm has been written in pseudocode to allow some numbers to be input. All the positive numbers that are input are totaled, and this total is output at the end. An input of 0 stops the algorithm. So if you're watching this on the recording, just pause this playback for a moment and see if you can find the 4 errors. Now, when I'm doing these, I'm just going to, actually what I'll do is I'll put this on a Zoom whiteboard. So just actually give me a moment. I'm just going to open up a Zoom session. Okay, so I've got the whiteboard open, and I'm just going to get a screenshot of this so that I can write on it, because it won't let me write without some help, basically. So where's my screenshot gone? There's my screenshot, put it on there. Okay. So yeah, so when you're approaching these errors in code questions, the best way you can prepare is just to keep doing these over and over again. That is the most important thing. And sometimes you might, especially if you're early on, you're thinking, oh no, I'm not sure what to do. I'm not sort of sure how to approach these. The best thing to do is to just keep doing these, because they will reuse the same errors over and over. Okay, so the first problem that we've got is we've got our first error. We're going to go through the so I'm just going to put my graphics tablet on. So the first thing that we're going to do is go through it line by line. Line number 1, exit equals 1. So I'm not quite sure about this one. If we're setting something to be 1 at the start, it might be right, it might be wrong. So I'm just going to put a little question mark by that one and sort of say, yeah, I'm not sure about that one. Let me just move that out of the way. There we go. So I'm just going to put a question mark by that one, and I'm not sure if that one is correct. But we can come back and we can have a look. And that's the main thing, is you are going back and you're thinking through each one. So this line number 2, while exit is not equal to 0, do. So if we are allowing some numbers to be input, all positive numbers are input until the total is output at the end. An input of 0 stops the algorithm. So that's the line I'm after. An input of 0 stops the algorithm, effectively this while loop. So that looks okay. So while exit is not equal to 1, do. And actually now I've read that line number 2, I think the exit one, that looks okay. So I'm going to say that line number 1 is actually okay, and I'm going to tick that one off. Now, one of the things I do also like to do when I am doing this sort of code analysis is I like to sort of section off the code into loops. And we've got a while loop here, and the while loop, the while loop, it starts here and it ends, well, it's supposed to end here. So I can actually see that there is a problem with the end of the while loop. It should be end while. Should be end while, but we've got an end if. So that's our first error. I'm just going to cross that off. And it should be end while. Okay, so that's our first error, line number 13. So I'll just write it down there. Okay, next line. So that one's got an error. Then inside the while loop, once we're in the loop, we're inputting number. That looks okay. I'm going to tick that one. And then we've got if number is less than 0. Line number 4. So that's not quite right because we're trying to get all positive numbers that are input. And that's a negative number. That's checking to see it for the negative number. So this less than is always a really good indicator, sort of less than, greater than, etc. Not equal to, less than, equal to, greater than, equal to. Just check those because it's really easy to put for them to put those sort of errors in. So that's our next error, line number 4. It should be greater than instead of less than. That line's okay. We can put the then on the next one. That's on that next line. That's fine. Line number 6. If we're totaling plus the number, so that's okay. That is totaling. And then we've got an else. So the else is slightly indented by the then. That's absolutely fine. I wouldn't write it that way. I'd sort of get it aligned with the if, but some people write it this way. Line number 8 is if number is 0, then we're going to exit. So that's okay as well. Line number 8. Line number 9 is fine, but line number 10. Yeah, line number 10 and actually line number 2, these two, it's not quite right. So while the exit is not equal to 0, so that actually, I'm just going to go back here. Not only have we got an error at the end, that not equals, you might have spotted this before me, should be an equals. So while exit equals 0, then we're going to loop. So yeah, that should be there. And sometimes you don't notice until you get further down and you kind of think, oh, hang on a minute, that's not quite right. The end if, that's okay. End if is okay. And that end if is okay. So that means we should have an error on this line here. Output, the total value of your number is number. So yeah, we're outputting this variable here, but actually it should be the total, not the not number. So that should be total. So that's our 4th error on that line there. Okay, so yeah, sometimes you need to spend time thinking about these. It is really important to make sure that you spend time thinking about these and really going through the code in the exam. And if you do get one of these in your exam, you are likely to get one in your exam. I'd say 90-95% chance you'll get one of these, possibly even higher than that. It's very rare for them not to have one in, but yeah, it does happen sometimes. Okay, let's move on to the next question then. And the next question is, yeah, so sorry, that's the answers there, by the way. And they've highlighted what the answers are as well. So, by the way, line number 10, they haven't highlighted all the possible answers. So there's a couple of ways you can deal with the while loop and the exit value. I chose to set it, you can actually set it to be equal to. So there's a number of alternatives there. Okay, let's look at the exam paper question. Next exam paper question is it's this one here. Describe how you could change the corrected algorithm to record and output how many positive numbers have been included in the final total. You don't need to rewrite the algorithm. So for questions like this, what we're really doing is just describing it in 4 marks. So this is actually quite a common question at the moment with them. So we're just going to say, how do you do a count? How many have we got? How do you do a count? So what would we do if we go back to the corrected algorithm? If we have a look at this, actually what we would do is somewhere inside that while loop, wherever we're counting a number here, sorry, wherever we're adding on to our total, then we would add a count there. So between lines 6 and 7, we would put count equals count plus 1, but we need to declare count as well. So if we go back to this code here, and if I just get rid of all the errors and just assume that the code is correct, all you do is you would do count equals 0, and then you would put here between lines 6 and 7, count equals count plus 1. Okay, and then out here at the bottom you would do output count with some text there as well. So to write that, how they want that in the question, because it says describe it, you would say I would create a variable called count, and set it to 0 at the top of the code. Then between lines 6 and 7, I would increment. So increment means to increase by 1. It's a very common term used in programming. The count by 1. Then after line 14, I would output the count, and that should get you 4 marks. Now you can use bullet points if you want to. That's absolutely fine. You don't have to. You don't have to write in sentences if you don't want to, but you can. Can use bullet points if you want to. So if we just look at the answer, so here to get the marks, you've got 1 mark per point, maximum 4. Initialize a new counting variable, set it to be 0. Insert a counting statement between 5 and 7, count equals count plus 1, and then add a new output after or at the end to output the count. Okay, so that is that question. They do have a similar question very often. They've done a question like this, very similar, but instead doing the minimum or the maximum. So really what they're after for knowing for this exam paper is finding the minimum, finding the maximum, averaging, totaling and counting. And those, if you can learn those, you can get lots and lots of marks, because they're in every one of them, or at least one of them will be in every exam paper. Okay, let's look at the exam paper questions again then and move on to the next one. And our next question, question 6, state 2 features that should be included to create a maintainable program. Give a reason why each feature should be used. So why do we have, or what could we do to create a maintainable program? So for this question, there are lots of answers. And if we look at the, so we're kind of writing 2 things for each one. If we look at the answers for this, they've got, so you can see the marking, 1 mark for each correct feature, maximum of 2, and then 1 mark for each correct accompanying reason. Why do we use them? So use meaningful identifiers. So your variables, constants, arrays, they need to have meaningful names. And I can't emphasize that enough. It's so frustrating when I worked as a programmer for different people. I go into a company and they'd say, oh, we need you to work on this and amend this code. and I'd look at it, and whoever had written that code had just, you know, written a whole load of x equals y type things, and it's like they've almost done it on purpose to make it look, you know, to make it difficult for whoever was going to take up their job, or, you know, once they'd left. So it's very frustrating when you don't use meaningful names. So yeah, so that's one example. It says to easily recognise the purpose of a variable, array or constant, or to enable easy tracking of a variable through the program as well. So that is a good one too. Use of comments is our next one, to annotate each section of the program so that a programmer can find specific sections, so that the programmer knows the purpose of that section of code. And it's quite a good reminder to yourself, if you're writing code and you are the only programmer, maybe you're writing something and you think, well, I've kind of had to do some really weird stuff here in this code. What am I, you know, why? Write a note to yourself, because, you know, in your future you will thank you for writing comments to say, I did this kind of weird thing here, come back to it, and yeah. Oh yeah, that's why I did that. Procedures and functions to make programs modular and easier to update or add functionality. So yeah, always, if you can, use procedures and functions, because it does help track everything. Now, there might be other things that you can put there, because that's just an example, but that's all they've got in the mark scheme. But if it's a reasonable, good way to maintain a program, then they will give you marks for it. Okay, next question. We are steaming through this one. Right, so we've got a trace table next for this one. So I'm going to try and get this onto my whiteboard so that I can actually write on it. Otherwise, we're going to have a few problems. And then I can, yeah, I'll do the flowchart as well. It is obviously a 50-50 chance that you'll get a flowchart or a, well, it's not 50-50 actually. That's a complete, that's not right. You will most likely have a flowchart in your exam, but they do occasionally have pseudocode. Anyway, let's have a look at this. There is our flowchart and there is our trace table. And I'll just move that down. Okay, so we have got a flowchart. So reminder of flowchart, symbols. We've got our terminators at the top, which are sort of ovals. We've got a rectangle, which is a process. We've got parallelograms, which are inputs or outputs, and we've got the diamond shape, which is our decisions. Now, with this, we just need to remind ourselves that when we're doing anything with this, with our flowcharts, or trace tables, we're only filling in the trace table when we are changing something in the variable. So the whole point of trace tables is just to track variables to make sure that your algorithm is working correctly. Okay, so I think this should work. I've just got a few issues with the layout. I always have problems. The trace tables and database questions, really tricky to try to get on your screen when you're trying to teach it. So hopefully you can see this okay. Okay. So I'll use a red pen. All we do is we are going to follow what the flowchart is telling us, and we're going to write into the trace table only if we've got an arrow to set a variable, or we have an input to input some variable as well. And I'm just going to make my pen a bit thinner because it's a little bit thick now. Okay, so And it says here, the table represents a two-dimensional array word, which stores the first half of a phonetic alphabet used for radio transmission. For example, word 10.1 is J. So there we are, 10.1 is J. I know the phonetic alphabet off by heart because my dad was a policeman and he taught me each one. One day before computers were used widely and mobile phones were in sci-fi films. Okay, so we've got start pointer equals 1. So we've got an arrow. So we're going to put pointer equals 1. I'll put that there. And then we move down. We've got input letter. So what's our first letter? Our first letter is F. So I'm going to write that here. Our first letter is F. We move down and we say, is word pointer 1 equal to letter? So word pointer, so 1. So index 1. So if I just explain that, pointer is 1 because we've just input it or we've just set it here. And then it's the element 1 of the array, so it's A. So is A equal to F? No, it isn't. So we follow the no and we do pointer equals pointer plus 1. So that means that pointer equals 2. So we then go back round here and we're back here. Is pointer, so that's 2.1, equal to F? So is B equal to F? No, it isn't. So we just increase our pointer to 3. We go around again, we're up here and we're now, is pointer 3.1, C equal to F? No, it isn't. So we just increase our pointer by 1. So we go up here, we go round. Is pointer 4.1 equal to F? No, it isn't. So we increase our pointer by 1 and we loop around again. Is pointer, which is now 5, 1, E, is that equal to F? No, it isn't. So we increase our pointer by 1. And then, sorry, that should be 6. And then here we are now on 6. Is 6.1, this one here, F, is that equal to F? It is. Right, so we can go in the yes one here instead, and it says output letter. So we're just following exactly what it says, and we do it on the current row. Is letter, so it's letter and then the actual contents of the variable F, so that's the contents of the variable, is represented by, and then it says word pointer 2. So we're on pointer 6. So 6, 2, so that's index 2, that's foxtrot. Foxtrot, type of dance. If you watch Strictly Come Dancing, you'll know that already. Okay, so we've done the first one, and then we go down here and it says another letter, yes or no. So we output that. Any outputs, so another letter. Obviously your handwriting is going to be much neater than mine. Another letter, yes or no. And then we move down, we input the choice. So that is our next input here, which is Y. So we put in Y, and that's in choice though. So it goes here. Go on the next line down. Is choice equal Y? Yes, it is. So we go up here and we set our pointer back to 1. So we're going to set our pointer back to 1. And then we input the next letter, which is D. So we input D. And is pointer, so that's 1, 1, so A, is A equal to D? No, it isn't. So we increase our pointer by 1 and we loop around. Is pointer 1 equal to D? No, it isn't. So we increase by 1 and we loop around. You can see where this is going. Next one is C. That isn't equal to D. But the next one for 4, it is equal to D. So that is D. So we're here, and is pointer, so is equal. So we go to yes, output letter D is represented by, sorry about my appalling handwriting, delta. And then we move down another letter, yay or nay, yes or no. And this time our input here is N for no. So we put that choice in here, input the choice, put it on there, and then is it equal to yes? No, it isn't. So we just stop. So they do sometimes stop quite abruptly, these, and that's just the end of our algorithm. So they give you a mark per column. There's 4 marks. You must get all the columns correct. Sometimes if you put things on a different line, that's okay, as long as it changes in the right place. But don't sort of put your first output up here. Always, you know, if you're here on this line and it says output, put it on that same line. Okay, that is that question. Let's look at the next one. And our next question is, identify the type of algorithm used in this, and then describe one problem that could occur with this algorithm if invalid data was input. So this type of algorithm, the way that it's going round, if we just have a quick look at the this here, all it is if you're checking to see if something in an array is equal to something else, that's just a linear search. You're going and we're going up by 1 each time. So it's just a linear search. Again, this is the only searching algorithm that you need to know for this exam. So yeah, it's a good one to make sure you know just how to identify it, because yeah, there is no other searching algorithm for this exam. Some of the other GCSEs, they do have a binary search, but you don't have that in Cambridge. So that's that question. It is a linear search, and then describe one problem that could occur with this algorithm if an invalid character was input. So what could happen with this if the incorrect or an incorrect value is input? So for example, the letter, or yeah, probably the choice is okay, but if you input a letter, say for example, you put in asterisk or ampersand, what would happen? Well, what would happen is, well, if we put something after M as well, or I think it shows first half of the alphabet, it wouldn't end. It would just keep going, basically. It would go to the end of the index, and then you might get an error. So yeah, you could get a problem in the fact that the algorithm would just not work. So how do we put that eloquently? So if we have a look at the mark scheme, the algorithm wouldn't stop because it would not have found the item it was seeking. Or you could say the algorithm would run out of values after the pointer reached 13, and therefore the algorithm would crash. So something along those lines would get you the marks. Okay, let's move on then and move on to the next question. And the next question, we have got some pseudocode. Okay, so write pseudocode statements. To store the string, the beginning is the most important part, in phrase. Calculate and output the length of the string and output the string in uppercase. So in some, oh yeah, they've told you how to do length of phrase, calculates the length of the phrase. They haven't actually told us how to do uppercase. So this is a fault with them. They're really not great. They tell you, oh, here's how to do length, but they don't tell you how to do uppercase. Anyway, if you want to pause this, if you're watching on the rewind, then do have a look at trying to write this. I'm going to write it in the whiteboard in a moment. Is that my whiteboard? There we go. Yep. Okay, so we need to store the string. It doesn't tell us whether or not we have to declare our variables. So I would declare your variables if you haven't, if it doesn't say, I'd declare them. So I'm going to say declare phrase, and it is a string because it's going to store a string. Store the string at the beginning is the most important part. So we do phrase and then arrow and then the beginning is the most important part. Okay, so that's the first one. And then we calculate and output the length of the string. So you can do this on one line. You could just do output length phrase, or you could do declare another variable strut length, and that is an integer, and we just set that variable str length is equal to the length of phrase, and then we output str length. I mean, I would just do it the first way because there's no sort of massive reason why you wouldn't do it that way. And then output the string in uppercase. So to do it in uppercase, we just do ucase. So it's output ucase phrase. So that's their preferred way to do uppercase and lowercase. So in Python, if you've been using Python, you would just do phrase dot upper with brackets on the end. That's the Python. But obviously they've asked you to do pseudocode. Don't do Python. But just to remind you, if you've been doing some Python, that's how you would do it in Python. Always answer in pseudocode other than the 15-mark question. Otherwise, you will not get any marks. So if you think, oh, I can remember how to do it in Python, but I can't remember pseudocode, you'll just get 0 marks. You might as well just not bother. What I would do, though, is just do your best and try and do your best with the pseudocode, because they might give you some marks if you've got it almost right. Okay, so that's the first question. And then we've got write the output your pseudocode should produce. So the first output is outputting the length of phrase. So that will output 40 because there's 40 characters in that. And then the second one, if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can remember this because I did this with another student the other day. So I know that it was, I can remember that it was 40. And then the string in uppercase, it'll just be the beginning is the most important part. Okay, so that is that pseudocode question. How are we doing for time? Okay, we've got about 9 minutes left. Not that I'm counting too much, but yeah, we can move on to some logic gates questions. Okay, so we've got a logic expression. Draw a logic circuit for this logic expression. Each logic gate must have a maximum of 2 inputs. Do not simplify it. Okay, so I'm just going to draw this on here, just so that I don't have to end up copying and pasting. And that's output X. Oh, it's Z actually, sorry, not X, it's Z. So when you're doing these, the main thing to do is look for the central gate. So if this is our output here on Z, then there's only ever going to be one gate here that's going to Z. And so therefore, we need one gate that doesn't have brackets. So you can usually identify that central, I call it the central gate. You can identify it because it doesn't have any brackets around it. And actually, if I write the expression on here, I can show you. There's some brackets. So it's Z equals, and then we've got an and then we've got B XOR C. So the AND doesn't have any brackets around it, so that must be our central gate. Now, there should always be one gate that doesn't have any brackets around it. You might sometimes get it like this. They have done this before where there's brackets around the whole expression, in which case you can just do your maths rule where you can just get rid of the outer brackets because they just don't count, they don't really matter or count. So that's your AND gate there. And then we've got two sides or two inputs to that AND gate. We've got side 1 and side 2. We've got side 1, side 2. So we pick a side, and this expression here, we're going to do this separately. We've got an OR gate in the middle. The NOT gate is never, well, they've never done it in an exam. They've never had a NOT gate that is the central gate. So effectively what we're doing is in this expression in the brackets, we're finding the central gate for that as well. So that one is an OR gate. That's not bad OR gate for me, actually. I'm not very good at drawing gates. So that's the OR gate there. We've done the AND. So we've got NOT A though. So if you have NOT A, all you do is you put a NOT gate before it goes into that gate there. And then on the other side, we've got B. So we just draw a line for the wire into that OR gate there. So that's everything on that side. And we can do side 2 now. So side 2 is just B XOR C. So our central gate is XOR. There isn't any other gate anyway. So we just draw an XOR, and there's my XOR. And coming into that is B, so we can just draw a dot and pull that in. And then the other side is C. And that is our circuit. I would recommend that you do write the name of the gate on it, just to be really clear, because I have marked a lot of papers in my time, and it's sometimes quite hard to tell, is it that an OR gate or is that an AND gate? And if you write on it, then the examiner knows. Okay, so our next bit, I think, is to do the truth table for this. Yeah, we've got to do the truth table for this. So let's do that. I will just draw my own, otherwise it's going to get a bit messy. So yeah, I'll put that there, and let's do the truth table. Just get rid of that and that. Oh, actually, I'll leave that on. Okay, so we've got A, B and C. And I'm just going to draw. You will get this all done for you. As you saw on there, it will all be filled out for you. They don't expect you to know how to fill out the zeros and ones, but I don't mind doing it. Okay, so there is the basics. So to do the truth table, all you do is you label all of the outputs on your diagram. So in this case, we've got NOT A. So I'm going to label that NOT A. Then this one's going to be D, and this one's going to be E. And so we're going to have NOT A, we're going to have D, and we're going to have E. And then finally, we're going to have Z. But we need to do the intermediary gates first. So all you do is you take one gate at a time. We'll just take the first one, NOT A, ignore everything else, and just do the NOT A. So we're going to go down here. We've got 0, so that's going to be a 1. A 0, that's going to be a 1. A 0, that's going to be a 1. A 0, that's going to be a 1. Then we've got a 1, that's going to be a 0, a 0, a 0, and then a 0. And we've ignored B and C completely because it doesn't count in that NOT A. We're just dealing with NOT A. Okay, so then we can move on to D. So what is D? D is basically not A ORed with B. So it's effectively this section here. So D is not A or B. So we can take our not A and our B and we're going to OR them together. So if you remember your ORs, with OR, everything is a 1 apart from a 0 and a 0. So if we had A and B and then our sort of X output, 0, 0, 0, 1, 1, 0, 1, 1, everything is a 1 apart from if they're both 0. So yeah, but that's what we're going to do with B or not A. So we've got a 0 and a 1, so that's going to be a 1, and we write it in the D column because that's our output. We've got a 0 and a 1, so that's a 1. We've got a 1 and a 1, so that's a 1. A 1 and a 1, so that's a 1. We've got a 0 and a 0, so that's 0. 0 and 0, that's a 0. A 1 and a 0, so that's a 1. And then a 1 and a 0, so that's a 1. And then we can do our E. So we're just taking it one gate at a time, one output at a time. Everything else gets ignored. So for the E one, what have we got there? We've got XOR. So remember with XOR, you don't even need to remember the truth table. Well, all you have to remember is with an XOR, if the inputs are the same, it's a 0. The output is a 0. And if the inputs are different, then it's a 1. It's exclusively OR. That's why it's called exclusively OR. Okay, so we have got B XORed with C. So we're just going to do these two here. We're going to XOR B and C. So 0 XOR 0, they're the same. So it's a 0. We've got a 0 and a 1, they're different. So it's a 1. They're different, so it's a 1. They're the same, it's a 0. They're the same, it's a 0. They're different, it's a 1. They're different, it's a 1. And they're the same, so it's a 0. We're nearly there, nearly got there. It's quite hard, a lot of work that we have to get for those 4 marks. We're nearly there though. We've got an AND. So we've just got D and E ANDed together. So we're just going to AND these two. And you can see looking down them with an AND, we don't even need to remember what the AND gate is equivalent for with this, because you're just looking for 2 1s. So if it's a 1 and a 1, then it's a 1. So we can just go down, look for 2 1s, and it's those 3. Yeah, that's good. And that looks good to me. And that is our final truth table result. So again, with everything, especially with a paper 2, it's all about practicing these questions. We have run out of time, so that's good timing actually, because we have got to the end, and we'll continue the next exam paper next time, because we've got the database section, so that'll be a good thing to carry on. The next session is on Wednesday next week. Is that the 18th, 17th of December. So I'll see you all. Take care, and